Great. Looks like I'm live. Let's actually see. Uh, let's confirm everything is working. Good. Looks like at least the chat is working. um, Everything else as well. Yeah, this with the world. So this is the first stream this year. Finally, took me a while. I did a little break for a couple of months, and now I'm back. The plan is to stream more frequently now, um, as of now, and this is the first. It's just the starting point, you know. Um, so let's quickly see what is actually. Okay, so here we go. This is the topic today. We'll talk a little bit about Solid, and of course, I didn't share the screen. Great. Starts very good. So let's first start. So the most interesting thing today is, or the most tricky part today is actually that I'm actually on call, and this means the stream can quite spontaneously end. So let's hope for the best and that this stream actually make it till the end. But yeah, I've changed a little bit since I streamed last time. So I've changed a little bit my studio setup. I've positioned the camera differently. I have now a little, or not a little, I have now a nice picture in the background, although it's a little bit blurred out. So arranged some things differently. Also, I have changed actually my my setup here on the computer side. So what has changed here is, since I streamed last time, is I am now on Linux. So last time when I streamed, it was still my WSL setup on Windows. It was just one PC. Now I have two laptops here. One is over there doing the coding part. So there's Arch, by the way, running on it. And I have my Windows laptop here for doing the streaming and a capture card and all the new stuff, all the crazy cool technology that you need to do this. Another thing that has changed since last time is actually, no, this has not changed. So there's still LazyVim, there's still Zealous, there's still Alacrity. But another thing that has changed since last time, when we talked about Gleam, actually, as the programming language to build this Cozy Coder project here, I've decided to go with a different framework instead, and also a little bit different architecture. Yeah, that's actually something we want to talk about today, and also to get hands-on, because this is today, of course, a coding session. So I will talk a little bit. I will hopefully also draw a little diagram to explain things, and then we will go deeper into and write some code and actually get something working, hopefully. Let's see how well this works. So here we are. If you are new to this project and this channel, so what is Cozy Coder? Cozy Coder is actually the website will be coming soon actually, and explain a little bit more about this. It's in preparation right now. But Cozy Coder is actually, as the README says here, it is your cozy space for coding with AI. So what does that mean? Well, the idea is basically to create a desktop application and let the desktop application provide you a chat interface and all the stuff. So it's actually not just a desktop application, it's a local first application. So local first is the idea to have something where the logic runs locally on your laptop. And on the other hand, you have also all the comfort of synchronization between devices and those kind of things. So the idea is to build it as a local first application and make and also give it a CLI. So because it's a developer tool, obviously. And the idea is basically to have something that is much better than integrating LLMs into IDEs, which in my opinion is a very limited way of working with it. And especially also providing the ability to have real-time collaboration on your chats and all the stuff. And there's a very strong focus on local LLMs as well. So this laptop is not the fastest one. So here it's always a little bit tricky because most of the things are running on the CPU. But if you have, for example, a modern MacBook Pro, you can very well run some pretty powerful LLMs on your local laptop. There's nothing wrong with it, and it just works, and it's quite fast already. So there has been some significant progress on local LLMs recently, and I highly recommend using them. And I want to make this much, much easier with Cozy Coder as well. So a lot of cool things or nice things that I think are very helpful are in this idea. And yeah, it is an idea yet, and we want to build it. Of course, you can see it here. It's under the Apache 2.0 license, so it's completely open source. Hey Dima, yeah, Ollama for the way. That's exactly the point. So when it comes to local LLMs, the idea is actually to really go for Ollama first as an integration point. But I also have thoughts about, well, let's see where this ends up. But there's also this ONNX runtime, for example, that you can, or it looks like you can embed this very well. And this allows you to put actually LLMs also right into your application without the overhead of Ollama. This might also be an option to add this at a later point, but Ollama is definitely a good first starting point. But there's one thing that I miss about Ollama, by the way. So I have my framework laptop with an integrated AMD GPU. And sadly, Ollama doesn't support integrated CPUs, integrated GPUs from AMD yet. So technically, it could use the GPU even on this Framework 13 laptop, but it doesn't support it, which is sad. I actually like it if you get the acceleration. That's roughly the talk about it, about the project. Last time we talked a little bit about Gleam, and the idea was to use Gleam, a very nice, interesting new language. You still can see my my support for the language here, wearing the Lucy still on my t-shirt here, but I decided to go for Solid. And I would like to explain quickly why I think Solid is such a great idea. And I think the main part on Solid is actually this idea of the fine-grained reactivity. So what fine-grained reactivity means here is that if you have, for example, so if you compare this, if you know React.js, you know that in React.js you have this state and then you have this virtual DOM, and whenever the state changes, all the components will be re-rendered. So you will execute the whole component tree, all the functions once again, render all the virtual DOM again, and you get a new virtual DOM rendered, and then you compare this virtual DOM against the real DOM and just apply the real changes, just the diff. But the problem with this is you have to recalculate everything all the time whenever something changes. And then you have this whole virtual DOM and you have to update everything and so on. And of course you have all the data is stored in the state, and it's also stored in the virtual DOM, and it's also stored in the DOM. So you have it several times in memory in the browser. And I don't like that redundancy and doing everything all the time again. It works, but of course there is some overhead. It is fast, but there's still some overhead, and I would like to have it more efficient. And this brought me to Solid.js, because Solid.js actually has a different approach. So basically what you do in Solid.js is this fine-grained reactivity, and I hope there's a good example here. So basically what you do here in this fine, I know this is not a good example. Do they have one with the user interface actually? That would be actually what I would really look for. Of course, not here where I'm looking for. Great. Yeah, great. So then let's see where. No, validating is exactly not what we're looking for. So basically, what this reactivity means is so there's this guide here, and you can read through it. It's a very great explanation how this works under the hood in the end. But what's really cool about it is that what Solid actually does is you create these kind of signals. So this looks pretty much like create state in React, but it is quite different, because whenever you change actually this state here, only the things that are subscribed to it are actually recalculated. So whenever you change, so whenever this set count is called here to change the state, or to change the signal, this create effect function here, exactly this function here within the create effect, that is given to create effect here, this function will be executed, only this function. And this even works with JSX. So it will not re-render your whole component tree and create a new virtual DOM. It will just directly update in the real DOM only the parts that have changed. And that's quite nice, because it has significantly less overhead at runtime. And it doesn't store, or you can implement this very well in a way that you don't have to store that much content or that much data in memory. And there's one example where this is really nice to see, that I've found here in the, where is it gone? I should have prepared the links. Was it fetching data? I think this one was it. So when it comes to fetching data, this is quite interesting, because what Solid.js provides is this create resource. And create resource is cool because the way it works. So they have this very, very nice example here where you have a component actually that, well, obviously shows some user data. They have something here with a switch and a mesh, but let's ignore these parts actually. That's also all fine, but not really the part that I wanted to show you. So what you have here is you have a signal for the user ID, just the ID, not this. So in React, you would probably create state for the user, and then you would put the user into the state, and then it would recalculate the whole component and re-render everything. Here, what you can do is actually you can create just a signal for this user ID, and when the user ID that should be shown actually changes, this resource will be triggered. So in this particular case, we have created a resource that is assigned basically, or that listens actually for updates on, or it's, well, I think subscribe is actually the right word here. So while by calling create resource, the user here is, or the resource actually is subscribed to this user ID. This here is a getter function actually, and it subscribes to the getter function. So whenever this signal is changed, whenever the user ID behind this is changed, then this resource will be triggered. And when the resource is triggered, it will actually invoke this fetch user function here, which is this one here. So it gets the current ID and it returns something, which is then obviously here in the user. And the interesting thing here also, the create resource is creating a signal, if you want it like that. So when we have some place where we use the user here below, for example here, when the user exists actually, so this is how you access then the user from this resource. When the user exists, well, in this case, we just stringify it and print it to a div, but it doesn't matter. It actually means that whenever you change the user ID, the fetch function is automatically executed again. And then only this part here, this little div here, and exactly not the div itself, but only this part here is changed. Only this little part inside the real DOM is actually updated. So this is, everything else just stays as it is. It is just this very, very tiny part of the real DOM that is actually changed, and it's only a little fetch call that is done somewhere in the background that is actually being triggered. So very, very low overhead at runtime. Because of this approach of fine-grained reactivity. And I like it. It fits very well into the rest of the architecture. Since I'm using Tauri and not Electron, this is actually a very good fit in my opinion. So what does it mean for the application itself? So as I said, we have the application itself is a desktop application. I built it with Tauri. So the motivation behind Tauri, just to catch up on that, is Tauri is an alternative to Electron, but it is much slimmer than Electron. This is one of the reasons is actually it uses just a native web view from the operating system instead of shipping the whole Chromium browser with every application. The other reason is it uses actually Rust to it is actually a Rust framework if you want it like that, but you can completely use it in a way where you don't have to write Rust if you don't like Rust. So let's quickly see how would this look like. So let's say you have here your browser. In this small version. That's interesting. So, how do you want to Westming a TUI app? You mean a TUI to put into the browser? There's some tools that you can do that. Is this what you mean, Dima? Okay, well, while Dima is thinking about this, let's actually continue on what I wanted to say, actually. So the idea is basically that, okay, let's quickly jump on Dima's approach here. So yes, I have thought about this. I have thought about a couple of things. I've also thought about using GPUI, which is actually the UI framework that is built by the team behind the Z text editor, which is also a nice, interesting thing, but it's just alpha and you cannot just embed it as a library. You have to use it directly from the GitHub, from the Z GitHub repository and stuff like that. So it's not there yet, but it's an interesting approach. But the TUI with WASM is also an interesting one. So I've seen some demos about that. So there's a library, I think it's called eGUI or something like that, that you can use to actually draw a terminal app onto a canvas in the browser. I've tried this out with some of those demos, and I think it still is a terminal app. You know, if something opens in my terminal, I expect it to behave as a terminal app. But if I open up a website or in my browser, or if I open up a desktop application with its own window, I expect this to not necessarily behave like a terminal app, but more like a desktop or a web application. And I think that's not what you get from it, because some things are just not working. I don't remember exactly what I was missing, but I think some things like selecting text and copy and pasting and so on doesn't necessarily work in all of them. And that's mainly because, well, you get just a canvas, and you have to put all the functionality that you are used to on top of that. So in the end, you're building your own terminal. It's it is, let's say, it is possible, but I don't see it as so really practical right now. So that's why I stick with the Tauri approach, because in my opinion, that's, of all the options to build a desktop application, it currently looks like the one that seems to work, or that is most complete right now, in my opinion. So let's quickly talk about the Tauri application here. So what we can do in Tauri is actually, well, a local first application isn't that different from actually a web application. So in a web application, what we usually have is this way of showing is weird. So in a normal web application, what you have is you have a backend and you have a front end. And in a local first application, you also have this, but the difference in a local first application is that basically also the front end will access the backend, but this all works inside the browser. So in a local first application, not only the front end runs inside the browser, but also the back end itself runs basically inside a browser engine. And at least when you use something like Tauri, if you use something like a completely native framework, of course, then everything is running somewhere else. But the basic idea is, maybe the browser is not the right word here. Basically, the idea is basically that this is the end user device. So both the front end and the back end are running on the end user's device. And to be fully complete here, what you also want is actually some data. And also the data lives basically on the end user's device. So that's the rough idea behind a local first application. And of course, then you can put some server behind this to synchronize this against other devices and stuff like that. But the fundamental idea behind this is I have the end user's device and I have the front end and back end and also the data store all locally, and so that people can work offline. And if the service vendor actually goes bankrupt, you can still use the software. That's roughly the idea. So when you look at this approach, when you use Tauri, you have different. Well, in Tauri, we have actually different ways to implement this. So in Tauri, we can, let's take the data out because it's making everything more complicated. So what you have in Tauri is you basically have the web view. So with the web view, you can have a front end and a back end within the web view. So obviously something that compiles to JavaScript for both the front end and the back end. And then you might have your data here somewhere in the back, somewhere on the operating system. This could be the file system. This could be a SQLite database, which in the end is also just a file system if you want it like that. And what you also have is then you have this small, tiny application around this, and let's give it a different color. Not sure if this is the best one, but you also have your Tauri application. So the Tauri app is actually a Rust application, which, well, you don't really have to write. It's mainly a main function that you that is generated by the Tauri by the create Tauri application, and it will just invoke the Tauri framework and then let everything run. But in the end, it's still a Rust application that needs to be compiled and that accesses here the web view and starts the web view, loads your front end and backend code into it and all the stuff. And in the end, the backend will do some invocation on the Tauri app through something called commands. And then your Tauri app will actually forward this to your data store and load the data and provide it to the backend. So this Tauri app basically acts like a proxy here. And the cool thing on Tauri is actually similar to Dino, which has a similar approach about security. Tauri is also a very fine-grained security mechanism built in. So if the backend wants to access some data from the file system, you have to explicitly allow this. You have to explicitly say, my web view here is allowed, or the JavaScript within my web view is allowed to access this file here. If you don't do this as a developer, then this cannot access it. So there's a lot of security being built in here. So that's actually something really, really nice about it. And that's pretty, I like the framework actually. It's very cool. And of course it's using Rust. And this is also a nice language. Not everyone likes it, but at least I do. So this is the first option how you can actually build this. So let's call this the first option here. And let's figure out to make this bigger. Okay, so this is the first option. So then obviously we also have a second option, which is this one here. So if you want to build this, what you also can do is you can put the backend outside the browser. You can just, or the web view actually, which is the browser. You can also say, I don't want the backend being here. I want the backend being somewhere here. And the way, and then actually your front end goes to the Tauri application, and the Tauri application forwards this to the backend. So the way how this could work is I did this in my first video about Tauri with Elixir. So I've built a little Elixir application that was running as a separate process. In Tauri, it's called a sidecar. And then you have a binary that is bundled with the Tauri binary actually. And then you can actually ship this. And this actually makes this web view here a little bit smaller and allows us to keep just the browser part smaller and let the backend live somewhere else. The cool thing about this is it doesn't limit the backend to JavaScript or something that compiles the JavaScript. It actually enables you to use whatever you want. And the cool thing is this is shipped as a separate binary, so this can also have a CLI. If you want to also enable a CLI functionality, this can be baked into this. And that would make a lot of sense, especially for Cozy Coder, where I also want to provide a CLI. This approach would make some sense. And there is just a few things that are a problem about this. So shipping this backend as a separate thing is, I would say, usually introducing a couple of new problems that you have to solve. Some of these additional problems is you have to provide this additional binary. So in Elixir, there's a way to do that, but it is quite difficult to make this work. In Golang, it would just work. In Rust, it would just work. How do you do this with JavaScript, for example? With JavaScript, you could use Dino compile to do this. So with Dino compile, you can actually create a single executable native binary that includes your JavaScript code or TypeScript code and a slim version of the Dino runtime, and then you can just execute this. But the problem is when you embed even a complete JavaScript runtime, this backend here will become quite big. And one of the big advantages of Tauri is that this Tauri app here just creates a very, very tiny overhead of less than 1 MB. And the web view here is just provided by your operating system. So actually a Tauri application can be very, very small. And if you then put a backend here, if you use Dino compile, for example, this will have at least 90 megabyte of binary size and is significantly larger than the Tauri app. So if you want to avoid Electron, because it's such a fat thing by shipping the whole browser and so on, and you switch to Tauri and then you put actually a Dino runtime into it, you basically lose some of the advantage again. So there's, but at least it gives you more flexibility. And of course, there is a third option. And this third option here is the one where we do it differently. So what we also can do is we can actually put, and now it will become interesting. Let's remove this and this. And let's put, okay, let's make this a little bit bigger. Now the interesting question is how to send it to the back. Also remove the colors. Good. So the basic idea here is that we have the Tauri application and our backend, and we put both of them into the same application. So what this means is actually this is just a Rust binary. So you can just use Rust to implement your backend functionality, and then you can access some data here and do other things with your backend, do the synchronization and all the stuff, and you just bundle it together with the rest of the Tauri application, not as a separate binary or not putting it into the web view. And this is actually a way that is quite powerful and also results in a very tiny solution. And I want to go for that one for several reasons. One of them, if you look, let's have a quick look into the code of Cozy Coder here. If we look here in the main RS file, so this is actually the code that is generated by the Tauri framework when you create a new application. So what we have here is in the main function of your Rust application, it will just invoke this run. And if we look into run, this is all it does. It just creates a new Tauri application and hooks in few things and some error handling and so on, and then starts the thing. So the interesting thing about it is what you also can do here in the main function, instead of calling directly this run function, you can put your own CLI in front of that. You know, you can wrap this line here with some CLI using something like clap, which is a pretty good CLI library in Rust. And you can only invoke this run function here if your CLI, well, if you have invoked the right command to do that. And this flexibility here is great, because then you can have a CLI and you can have and you can have a backend and all of this stuff all being built in the same tiny little Rust application. And it's just one single binary, quite small, very efficient at runtime because that's what you use Rust for. And it uses a web view to load your JavaScript code, which then doesn't have to be very much of JavaScript code. So this also can be just a very tiny layer. And yeah, this is an architecture that aims more for keeping everything very slim. And that's the one we want to go for. So the backend in Rust, some data somewhere locally stored. There will be some synchronization behind it, and the front end, of course, in a web view. And this web view, in this case, will be written with Solid.js. And Solid.js, because of the fine-grained reactivity, fits very well in this approach of keeping things very slim and lean and making sure that you avoid unnecessary overhead. And hopefully this means the application doesn't use much resources, is very small to download, and also is behaving very fast so that people will not recognize that this is actually some browser running locally where they are clicking on. They might still see it, but it might be less of an issue regarding the speed. So that's the idea behind it. Let's then look into Solid.js from a practical point of view. So if you look at Tauri, at the documentation here, where's the get started? There's for different front-end frameworks something in here, and no, where's the documentation I was looking for? Okay, there's no documentation for that. But if you create a new Tauri application, it offers you different things to actually create. So you can select between something like LabTOS, which is Rust based. Well, you can say I want to build something with Rust and WASM, or I want to build something with TypeScript or whatever. So you select the language, and then you select actually a framework. And although it's not mentioned here, but Solid.js is one of the options there. So when we look here actually at the code in my application, then we should see, well, there's an index HTML, but there's also an index TSX file. So I've selected TypeScript and I have selected Solid.js here. So this is actually the code that Tauri created for me. And as you can see, this is just simple JSX, as you have this in React.js as well. The difference is that that Solid.js just behaves differently at runtime because of the fine-grained reactivity. But this is a component. We can go into the component. As you can see, we have a signal for a greet message. We have a signal for a name. We have a function greet, actually, that sets the greet message. So it basically calls the greet message setter here above. So what are we doing with this? Let's go a little bit down. We have some HTML that is created. Interestingly, the whole component is just rendered once. Only those things that are created as a signal or an effect and things like that are actually executed also later. So this will all be rendered once and never executed again. But what we see is actually we have here the three interesting parts. We have a form here with a submit handler where we just call the greet function. So whenever we submit, actually, so whenever we click the submit button, then the greet function is called. And when we look here in the greet function, it just, it invokes a command and the result will be set here. So what is a command? So this invoke function here is the functionality from Tauri. There's also a link where you can look for it. So this greet command here, we have even seen it already. It was in the librs here in this line 11. So what we do here is we actually build the Tauri application, and we mount basically this handler here. So we generate a handler, a Tauri handler, wrapping this greet function. So when we look here in this greet function, this is a function, a Rust function that is declared as a Tauri command. And what it basically does, it gets a string as an input, and it returns a different string, basically. And it is here in line 11, it is there's a handler being generated from this command, and this is actually being invoked or mounted to the Tauri application. And when we look here at this invoke call, greet is actually the name of the function and also the name of the command that is generated from it. And we give the name here, which is actually just the value of the name setter. So what this means is that that whenever we click on the submit button, we will actually call the greet function. The greet function will actually invoke this command and therefore take whatever is here in the name, and it gets back this Rust or this string generated by Rust, set it in the greet message signal, and then the greet message, where is this one used? Here. So below the form, there is actually this greet message. And so what happens is that when this call to set greet message happens, so in the moment where this is actually called and the new value is set into the signal, just this little tiny part here, will directly be updated in the DOM. So it's probably just an inner text update to exactly this p tag here that happens in the DOM in the end. And it's just that. It's nothing else. It's just we update the signal, and there's a subscriber that is actually updating this tiny little piece in the DOM, and that's it. What we also have, we have a change handler on the input here. So whenever we enter something into the input, there's a change handler and it will set the name. So that way we store actually the current value that we type into this input here in create signal. What we can do next is we can actually run this application. That's quite easy. We just run cargo Tauri def. If you just want to try this out yourself, you can just clone the repository, and if you have the tool Mise installed, it will also automatically install all the tools you need, including Rust, including Dino for running Vite in the background for building the Solid app, and it will also set up the Tauri CLI for you. So you don't have to install any of this yourself. Just run Mise install. So here's now the application running, and well, this is actually the default application that you get from Tauri, and we can actually enter a name here. Let's say we are the cozy coder, and when we submit this is actually the string that is this greet function in Rust being created. So you see, it's a very, very simple application, nothing very special. Of course, this could also have been running in the background, and whenever we change some code here, the Vite build will just rebuild it and reload it. So we have a lot of hot reloading in it. This even works for Rust code. If you change the Rust code, it will also reload and restart the application, but this takes a little bit longer because it's Rust. It needs to compile a little bit more. Yeah, so that's basically it. Brings us back to the question, what will we do today? So plan for today is actually, now I've talked a lot of things. The plan for today is to build the following. We want to say we have this nice little browser window. Doesn't be that big. We have this nice little browser window, and within this nice little browser window, how can I? This is in this nice little browser window, we want to put, well, this will become a chat, obviously. So what we want to do is we will have, let's put this on the bottom. Want to have some place to an input to enter your message to the LLM. And then we will have the user message that you already entered. And then you will have maybe a larger message here from the LLM. Well, actually, usually you call this as an assistant. What's wrong? And so on and so on. So basically, that's how a typical chat application looks like. Of course, this goes on and it just doesn't stay like that, but a very simple chat application. We will probably not complete it today, including calling a real LLM using a llama in the background, but we will at least start building a crappy user interface with Solid.js. So we want to figure out actually how do we build this. And since I'm not a front-end developer, this will be even more funny because I have to recap a little bit on some things and how they work. So let's do that. So what we want to do, obviously, is first of all, we want to get rid of all this stuff that has been generated. But what we also want is, of course, we want the input here where we can enter something, but we don't want this message anymore. And now, let's again start the Tauri application. We only have this part, and we don't want to call this button. This should be called send. And what we want to do is we want to show this above. Let's start simple. What we want here is the greet. No, it's called message. Exactly. That one. entered. Great. So, well, obviously the response is not exactly what we want to, but we can actually play with it. Let's use the greet function as a dummy implementation. So what we do is we have the greet message, and wait a second. What we want to do is we want to do it differently. That's the point. Let's create let's create the assistant. We start with the simple case where we only have one user message and one assistant message. So let's say we have the assistant message, and the assistant message is, oh, come on, is a resource. Pick the right one. And the resource requires actually something to subscribe to. Let's start with the name, and it requires something that is fetching. And as we saw, the fetching happens in the way that we have the name, and then there is some function that we can actually invoke, and that will return something. Let's say, what will we do? We will actually call greet. Just do the invoke. So by doing this, let's remove that one. So by doing this, what we actually do is we call this invoke here, and interestingly, we can even say, let's do it this way. So we can provide the name here as a string. And instead of using this function here, we can just provide greet. So what we do here is whenever the name changes, the greet function will be invoked, and the assistant message will become the greet function. And what we can then do is we can print the assistant message here. It is void. That's interesting. Let's look into the resource, into the documentation. That's why we have it. Learning is a great thing. So let's see. What are we doing wrong? We didn't return. I don't use I don't use TypeScript that much. Why do they require it? Great. Promise of unknown. The interesting question is, how can we make this thing. Do it in a simple way. I hope I've set it up. Let's give Cloud a try. That's not what I wanted to enter here. This works. That shouldn't. Confused. Just want to copy. Let's do. Let's try it this way. Yes. It's looks like the new Vim solution doesn't work as expected. Maybe something to fix on another day. So I have a simple TypeScript function, and it returns a promise. Let's see what Claude has to say about that. Let's hope for a very simple answer. Um, string return. Can't I just do this? Let's give this one a try. Is this all it needs? That would be fun. This work now? Looks like it worked. Um, let's say here it is. Yeah. Right. Okay, looks like it worked. It's just a declaration of a type. Great. Sometimes things can be so easy. Let's continue. Um, what else do we want to do? So the first thing is we want to not call, well, whenever the name changes, then we show the assist, or we call the resource here and show the assistant message. The cool thing about this is actually that only when the assistant message is changed, we will actually render it here, which means that we will just fetch it on the fly whenever needed, which is cool. We do this right from the backend. The next thing is we want to change here the on submit, because we don't want to change the greet. What we actually want to change is the user message. So let's not call this one the greet message. No, not this one. User message. And of course we have a set user message. And to update this one to the user message. And we should also call this one the user message. And here on submit, we invoke. What we do is actually on change, we set the user message. And the user message is this user message. So now we have that part. So whenever we enter something, we will update the user message. Then we will. That's exactly not what we want. That's exactly not what we want. What we want is we don't want this here, but we want um, that user message, but how do we actually get now think that's the... hmm. So the idea is that we cache this somehow in somewhere. So what we do here is we set the input. Chat input. I'm pretty sure there's a smarter solution to this, but we will figure this out later. Let's make this work first. So um, so whenever we change this, we update the input here. And whenever this button is clicked, we actually set the user message to the input. And I don't know if this works. Against the rules. Doesn't great. Um, at least it doesn't work fully. Why is this? So what we do is we set the input and then we set the user message to the value of the input. And interestingly, this works. So now we get the user message updated. And when the user message is updated, it is rendered here. But what doesn't happen is the refetching of the resource. So we don't call the greet function again. The question is, why is this? Let's quickly go back to our example. So here we have bound this to the user ID. And we have an input on input. Yeah, that looks much easier actually. Instead of on change, input, don't set input, we set user message. And then we actually don't need the form at all, which is even better. I think at least we don't need it. Let's see. Form disappeared. No, that's not the behavior I wanted. No, damn. Sorry for that. So the question is, signal and we have a resource. The resource is updated, is bound to the signal and calls dispatch user. And the input signal is updated. We also need to import this, I guess. Try to do this as well. That's watch that because it's a thing. So this doesn't work because we don't set the user message now. So what we get is we set the input, but not the user message. Did I break this? Hey Alex, how's it going? Welcome to the stream, actually. Oh, no, sorry for being late. That's totally fine. And all the things you missed, you can watch them tomorrow in the recording, which will also be available on YouTube. So nothing you really have to miss. Just gave a little introduction into Tauri and also Solid.js. So feel free to watch that again tomorrow. Now I'm trying to build something with Solid.js, and so basically the idea is to do this. I want to put some input here on the bottom where I can enter some text, and then I show the text here on top and some fake assistant message, the typical thing that you expect when you use a chat. So think of this here in Claude, where you enter here your message and then the message appears here on top and Claude's answer comes next to it. So of course it will not look like that nice, but that's actually what I want to build. The reality currently looks like this here, where I enter something and nothing happens. So and I wonder why this is. So let's quickly go through the code here. So basically what I have here is I have something called a signal. In this case, the user message. And what I also have is here an input. And the input, let's actually remove the button. The input on input, so on the on input event, it will actually invoke the set user message with the value of the current target. So set user message is actually the setter for the signal, similar to state in React, at least in this particular case. So whenever this is called, this user message code here, or this code here, which fetches the value from user message, should actually be re-executed and the message should be updated. The other thing that should happen is I created here a resource, and this resource is also subscribed to the user message here. And whenever the user message changes, it should actually invoke the greet function, which is doing an invoke this is actually a function from the Tauri framework, which invokes some backend code. And the backend code in this case is this Rust function here that is executed. It's some dummy Rust function that does the job for the moment, just returning some, let's say, almost random string. And then I return the string. So this assistant message becomes actually the value from the Rust function, or the return value from the Rust function. And then actually, because it's a resource, there's a little bit of nice stuff on top with loading behavior and also error handling. And in the end, I want to show the assistant message here once it is finally loaded. But the truth is, this doesn't work. And the only thing that I didn't try yet is just to restart the application. Sometimes, of course, this can also help. So let's give this also a try. Um, hey, at least that part works now. But we get an error, and the error is empty. Wonderful. So at least we now see that now that we have rebuilt it, we see that this user message is shown here. So the signal stuff actually works. So whenever we enter some text here, it's actually not the right behavior I want. Yes, greet. Ah, good point. Yeah, you're right. That's that. Oh no, not again. Damn. Uh, Once again, locked actually here on my screen in the wrong moment. I should maybe have a different shortcut for that. Um, but you might be right. That's actually why it's good to have a stream. But but seriously, is this a problem? It's TypeScript. Probably it is. It's probably even in other programming languages a problem. Let's see if this fixes the problem. Once again, restart the application. That's the error. Doesn't change the situation. So even if greet is defined before, it doesn't work. The question is, why doesn't it work? Um, so yeah, it is. Zelish is definitely a cool tool. Uh, as much as NeoVim is, that's also a great tool. So let's go back to the documentation and have a look into that. So basically what they do is pretty much the same. They define the function. They actually have the signal here. They bind the resource to the signal and then declare the function here. And then they have this user, and we use the user pretty much in the same way. The weird thing is actually that there isn't even something like an error. And I have a suspicion what goes wrong. That doesn't work. Thanks, Rust. Oh, of course, now this takes a little bit longer um, to restart. So the cool thing, actually, I mentioned this earlier. Tauri has hot reloading both for Rust code in the backend and now we got even some outcome. Let's see. Very nice. As you can see, the outcome is bullshit, but it now works actually exactly in the same way as I at least expect it to work. As you can see, Tauri also has hot code reloading even for Rust. So basically, what happens is that when you change the Rust code, it will stop the application and recompile everything and restart the application. Of course, when you just change the code when you just change the code in TypeScript, it will do hot reloading in the browser, so there is no restart of the application and it compiles much quicker. But of course, this is not how things are written in Rust. Now things become really interesting because now we have to figure out what are we actually doing with um, our argument here. So does this actually mean that it can deal with it? Yes, it can. That's actually pretty cool. At least that works as expected. So we pass in the user message here, and we can declare this as a user message, but it looks like actually declaring this as a Tauri command has a meaning. So there is a binding to the variable called user message from this object here, and this object can have several keys, and the keys are bound to the names of the variable or the attributes of the function in Rust, which obviously makes a lot of sense to me, but it's easy to forget. I think this is something if you use a framework like Laptos, which is very much like Solid.js, but just in Rust and compiled to WebAssembly. You might even have the chance that the compiler can even catch those cases. But I haven't tried it yet, so and I probably will not. But yeah, looks like we now have this working. But it's, as I said, it's not exactly how I want it to be. So the behavior I want to have is that I enter something here, and when I click return, it will actually put the user message here on top, and it will actually update the assistant message. And that's not exactly how we are right now. So what we will do is let's start by adding this. We had this before already with the input. We will get there. Yes, you should check it out. That's a very good idea. I really enjoy it. So let's create another signal here. And well, just a string, I think. And we will set the input. Yeah. And I wonder, is there something like um, submit? Interesting. Can I really invoke on submit on this one? Let's give it a try. So what we want to do then is we want to set the user message of or from the input. I think we can. Well, let's first validate it works. Yeah, he is declared and not used. I know that's not really my problem right now. No, there is no submit. Yeah, the interesting question, in my opinion, is if this is really well. We had before this case with the form. Maybe there's something in the solid documentation. Maybe I'm just looking too short here. Is there something about routing, navigation, fetching, complex state management? That's not really what I'm looking for. Event handlers. Understanding JSX. think I know how we want to do that. It's probably not really what I was looking for, but this looks quite good. Um, and yeah, let's start with this approach. I think that's a good starting point. So we give this a ref input. Just a variable. Okay, so we have just a variable input. Then we create a ref for it. And then we have a button on click. We actually, well, we create a task. That's not necessarily what we want to do, but something similar. Okay, that's something we can work with. So what we want to do is have this one. So we will not need this, but let input. And then create a wrap, which is then referencing input. And then the button, no corresponding closing tag. Did I really copy? Ah, come on. That's and then we say possibly undefined. What we do is some we do is input. We do this correctly, and then TypeScript is not undefined. Is the right way to do this? I don't know. Actually, we don't need this trim. This doesn't make sense. Oh, wait, isn't there something like this in TypeScript as well? Can also do what? Yeah, that's exactly what I wanted to do. So why didn't it work? Maybe because of that. Yeah, I think I can do this. I can do this. If type off. You mean if you're a customer? The type of input is not could be so easy if it was not TypeScript. Then it does not work. Then not return. If type is not undefined, I can still not do anything on this. Why not? What's wrong here? By the way, how is the quality of the video on the stream? This is for first time I wanted to stream actually in 4K, and I'm not really sure this works out. Alex, what I want is very easy. What I want is actually I want to set the value here of this input field. So basically input is a reference to this input field here above. And what I want is when I click the button, I want actually to reset the value of this input field to an empty string. So that's the idea. And yeah, the question is why not? Why doesn't it work? Maybe that's also not really what we want to start with. Let's keep it simple. So what we really want to do actually is we want to set the user message to input dot, and we do this only in, wait, that user message or input dot value. And now what was system.js input.value or something like this. That's exactly what we want to. But this, we just set it to this. So property value does not exist on never. So the question is, why is this called never here? I guess I have to give this a type. But the difficult question here is, what is the type? HTML input. There's something like a text. It's probably an input. That's a wild guess. Okay, let's do it. Let's do it the hard way. Yeah, it looks similar to React, but it's not, because things are so not everything that works in React works in Solid.js, because some things are executed and some things not. So it always depends on where you define your code. So because in React, you have the component function, and the component function is always executed. So whenever the state changes, your function is executed again because your component is re-rendered. In Solid.js, this is not the case. If you access, for example, a getter within the JSX in the HTML, it's in the context, then it gets re-executed. If you do this just outside of the JSX, it's not re-executed. So then you have to wrap it into something like an effect or something like that, that is able to subscribe to a signal or something like that. So it gets re-executed, because the function to render the component is always executed just once when you render the component, and afterwards only the parts within the component that really change and are in the context are actually re-executed. So this is much, much different. The advantage is this is much more efficient at runtime. The disadvantage, of course, is you have to be more careful about what is executed and what is not executed. But I think it's not that difficult because the rules are very straightforward. But this here is just a TypeScript error. And I don't get how to resolve it, because I'm not really a TypeScript developer. It's actually the value, the the see what Claude can tell us about this. Claude can make mistakes. Really? Can't believe it. Let's see what. Did I copy the? No, I did not. Okay. The error appears because TypeScript doesn't know the type of input ref. Yeah, that's true. In Solid.js, when you create a ref without typing, it defaults to never. I don't think that this is necessarily Solid.js related. Let's fix this by probably typing the ref. We just put a... I was very, very close to it. This here, okay. Interesting. And then we still have this here. Still get an compile error, but instead the ref will be defined. Okay. So we annotate this as an input element and non-null assertion operator when assigning to ref. This tells TypeScript that input is an HTML input, blah, 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 which is a property. Yeah, I know. Solids type ref creation. Sufficient for this use case. Great, I know. Now, variable input is used before being assigned. I love it. It's used before being assigned. Pretty much the same here. Next, there's a function which calls set user message input. Before. Let's see. That's why AI can be helpful sometimes, sometimes not. Starting with the signal. We can fix this by using let with proper initialization. Is a very bold statement. So here it makes this a signal, and then it uses ref set input and accesses like this. Okay, that's an interesting solution. Well, let's see if this works. I'm open to it. So we do it like this. Do it like this. At least it works now. You can also make a union type in TypeScript with null. Yeah, I know that you can do that, but I'm not sure if this would have helped in this particular case. I think the problem here is that something with the assignment was wrong, but I don't know why, to be honest. This is actually the part that I don't fully understand. But let's also be on the safe side and restart our application. So now we have the assistant. So let's enter some text. Click the button and whoo, that's exactly how it should be. That's exactly the behavior I wanted. So great, it works now. We have a user message. We have an assistant message, which is some weird, ugly text randomly generated. I think this is actually a very, very, very good mocking of LLMs. Just randomly spitting out some text, more or less. Interesting. I didn't know that it's possible to send uh, some emojis here. Nice. Thanks for showing me that, Alex. Very cool. We have some working code. That's fantastic. Um, let's be honest, this code is not perfect yet. There's still no real LLM, and this is still not a chat. It's just something that is one message, but at least we have something. I'm fine. I'm happy about this outcome. I still would also like to have this. I don't think that works yet. At least I would be surprised. Just pressing return doesn't work. We have to submit the button here, which is exactly what I expected to happen. So it's not a bug. It's just correct. But yeah, that's actually some first outcome. Let's actually commit some code, but first we have to clean things up. So this function can't be named like this. It must be, what would be actually a good name for the function that sends the message from the user to the LLM and then gets back the response? Probably something like send message, send prompt. Sure. should probably call therefore this also becomes prompt. So this becomes oh, I don't know. I think send message and prompt is at least prompting is something in AI that everyone uses, kind of. Converse is actually, I don't know, it's, I haven't seen this being used in such a context, to be honest. Um, so we have this part, and we have this assistant. Of course, it doesn't look very nice, but that's for another day. And let's actually commit some code. We have just this part. And then we can simply create a new branch. Nice. We have some first code. And the very cool thing is, it exactly took me 2 hours to get here. We are at 23 o'clock, and this is exactly 2 hours now on stream. I started exactly at 21 o'clock, and we have committed something very, very nice. So I will end the stream for today, but the plan is to probably come again on stream this week, maybe on Friday evening. That's the hope. I'm not sure if I do the stream on the weekend, but at least I hope that I will make it on Friday evening. Um, and of course, there will be definitely a stream next week, and we will continue that. So the plan is to continue working on Cozy Coder and going on with this nice little Solid.js stuff. I enjoyed it today. And if you want to be on, follow the chat. No, not the chat. Follow me here on YouTube. Follow the channel and get notified by it. And see you next time when we are all back here. Thanks, Alex, for being subscribed. Really like it. Right. So then, let me say goodbye for today and see you then hopefully on Friday or next week. Bye.